Hi everyone, this is Colin McNamara from Austin LangChain AI Mug. I want to introduce a video by Karim Lalani. In this video he covers the integration of Model Context Protocol, OpenWeb UI, open-webui pipelines, and LangGraph. All these concepts tie together, really a complete solution that we've been covering here in Austin. So without further ado, here's Karim.
I had been working on some AI imaging related tools in the past, and Cam really inspired me to sort of take a closer look into MCPs. A couple of weeks ago, when he was working through his presentation, we got together and the walkthrough that you just saw, we did on my computer just to see if we can replicate it to work, and that's how I was able to set it up on my machine. And that got me thinking, because I had done a previous lab with Cloudflare Flux imaging as well. One of my showcases showed that. And this was sort of like, okay, here's an MCP version of that. Same thing. It's hosted by on Cloudflare's edge. It's using the AI workers. But then there's I did another follow-up on that one that did image generation on your local 4090 based workstation. I have a ComfyUI setup at home. Who here is familiar with ComfyUI? Stable diffusion. Yep. Cool. So, so I have a 4090 setup at home. I connect to it externally through Cloudflare tunnels, and so that I can expose that functionality out, if I need to use it while I'm on the road. But after spending some time with Cam on his MCP exercise, I got to thinking, and plus Ricky also inspired me to sort of take a closer look into OpenWeb UI pipelines. Who here is familiar with OpenWeb UI? You heard it a couple of times today. And who knows about the pipelines? So OpenWeb is a chat interface for similar to ChatGPT, but it's for not just it's for any kind of models or any kind of workflow really that can use a chat front end. And initially, it was basically primarily a client for Ollama. Similar with Ollama. Few hands. So with Ollama, you can run open weight models locally that are supported. Most of the Llama family of models are supported. Microsoft's 5 family is supported. The newer Qwen and DeepSeek models are supported. Anything that is GGUF has a strong likelihood of being supported, and they do have a good interface with Hugging Face as well. So you can specify, you can just point to a hosted GGUF model on Hugging Face, and it'll just download that if it's not already part of the Ollama library. And OpenWeb UI started out as a front end for just basically a front end for Ollama. So you could do ChatGPT type stuff, but with your local hosted models. But they started adding more functionality, and soon it became, I guess, clear to them that people want to add more models, more functionalities. And while you could do some limited extensibility work within OpenWeb UI itself without through their functions and actions tooling, but you were limited by the fact that you had to, if you were bringing in any additional dependencies, you had to install it on the workstation or the server that was running OpenWeb UI and restart it every single time. You need to update that. So that's where the idea about pipelines came about, where pipelines exposes you to a more feature-rich, I wouldn't call it featured, but an external interface into what used to be functions, but it runs in a separate Docker container. So what that means is you don't have to keep restarting your Olama instance anytime you are installing a new workflow that requires additional dependencies. You can have multiple pipeline servers, and they could be each pipeline server could be responsible for a collection of workflows, related or unrelated. So that's, let's say, that's my socials. Okay. The nice thing about my presentation is I can go ramble about because Cam already did all the introduction to MCPs. So you probably remember this flow. So I don't have to go through all explaining about what MCPs are. We're just going to build on top of what he presented. We will LangGraph. Who here is LangGraph? That's good. So LangGraph is the agentic SDK, I would call it, loosely, from LangChain, allows you to build agentic workflows and applications. Recently, they also, so initially, when they released the first iterations, it was purely a graph-based API, right? So you had your state definitions, you had nodes and edges that you would combine to create a graph that would represent your workflow, and it would have an entry point, and then nodes would be connected to other nodes through edges, and it worked almost like a state machine. You started it, and then you could go through it, and then they started adding features like human in the loop through interrupts. They added more functionality like memories and checkpointing and stuff. Recently, they introduced what's called a functional API, which is an alternate way of creating LangGraph workflows, but in a more programmatic way, more imperative way. So you no longer have to build a graph to represent your workflows, because more often than not, you already have your code. Like if you're working in Python, you already have your logic laid out in Python. Having to convert that over to the Graph API could be seen as an overhead that not many people would be interested in, because they already have something working. It's just missing a few bells and whistles, a few enhancements that they could benefit from LangGraph, and the Graph API might prove to be a little bit more for overhead to sort of or to venture in that direction. That's where the functional API, I think, shines, because you can now work within your work within your idiomatic Pythonic way, but start bringing in these features like persistence, human in the loop, checkpointing, streaming in your existing Python code. I went a little basically with here, and this is some of the documentation. None of this is my stuff, but basically, you, depending on what your comfort level is, what your preference is, you could go one way or the other. With the Graph API, you get a little bit more control over the flow. You get a bit more of a state machine, a DAG-like workflow. Versus with functional API, it's more imperative, more programmatic, more type workflow. State management, you do get fine-grained state control with Graph API. With functional API, you don't have that. You're basically just using your variables and your objects as you see fit to manage your state. Checkpointing is available in both. However, where it differs is with Graph API, you get explicit checkpointing. Every single time the workflow moves from one node to the other node, it's checkpointed. With Graph, it only, with the functional API, checkpointing works on specific, because there's no such thing as nodes and edges there. So they have, you do get some benefits of checkpointing. So at the end of the execution of the workflow, it's checkpointed. If there's any human in the loop interrupts, they get checkpointed. And then let's see, visualization. Graph API is easier to visualize because, I mean, you have a workflow that is represented as a graph, and they already have tooling built into LangGraph Studio that lets you sort of, as you're walking through your code, debugging through it, you can see where it is. In functional API, it's your Python function, so there's not much you can do in terms of visualization there. But again, depending on what your comfort level is, what your preference is, you can achieve pretty much similar outcomes from both, with a little bit of variation maybe. OpenWebUI, I briefly talked about it. It's a front-end web interface for your own, for your locally hosted, or now with pipelines, you can actually connect to any kind of external workflows as well. So they have a pipeline for ChatGPT, for instance. So instead of going to, chat.openai.com or chatgpt.com, if you have your own API key, you can stay within OpenWebUI and access your GPT models. They have pipelines for DALI. They have pipelines for Anthropic's models. They have pipelines for Cloudflare hosted worker AI models as well. Things, like I mentioned, is a way to extend functionality to external workflows. They may or may not be LLMs. So one example would be, say you're building an agentic workflow, and you need a front end to either to test it, or maybe that's the chat front end is what you need to deploy it. You can put it behind a pipeline wrapper and make it available as a model within OpenWebUI. So you can select it from a drop down. So, and that's how some of the I think Ricky, you did a demo early on. You showed how to use a LangGraph or a LangChain workflow, but it's now hosted behind a pipeline. So you have a nice web interface. Our initial demos would involve creating a Streamlit UI to demonstrate some of these things. We would put it in front of a chat interface we built with Streamlit, but with something like OpenWebUI plus pipelines, why even go through that effort? Just create a simple wrapper around your workflow and just have everything within a nice UI. ComfyUI. So for those who are not familiar with it, Stable Diffusion and similar workflows, ComfyUI is one of the front ends for that. Another front end that you might have heard about is Automatic 1111. Comfy is a more node-based workflow. You have these primitives, nodes that you can then connect with each other, and information flows, inputs flow from one, from left to right, depending on which way you're going, and then basically you're collecting information, all the necessary parameters before you run it through the model, and then the output that you get, you might have other nodes that could then process some of that information before you get the image out. Comfy is not just used for image generation, any kind of workflows. There's both image and video generation. There's some controller workflows. There's plenty of stuff that's out there. You could even use it for non-image generation stuff. But this is just what it's most popular for diffusion and flowchart based models. Okay, so that was all the information that you needed to follow with this. So what I'm going to demonstrate, something that I've been working on, is a Comfy MCP server. So what Cam demonstrated was a MCP server that was a front end for the Cloudflare's Workers AI model for Flux. I have like I mentioned, I have a 4090 at home. I have Comfy running. Comfy does work in API mode. So I had created a MCP server as a front end for that. So it basically initially all it had was a generate image. You give it a prompt, it would pass it to Comfy or to a predefined workflow. It would return back with the URL of the image that was generated. Recently, as I was working for this showcase, I added another tool to it called Generate Prompt. The idea being that you might not always know, you might have an idea of what you want, but you might not have the whole prompt. Or if you're like me, yeah, I need a parrot with a cowboy hat, but that's the extent of how much I can articulate about it. And we know that with some of these image generation models, the more you can articulate, the better quality results you can get out of them. So the generate prompt essentially does that. The idea being that you give it a topic in as few words as you can, and then it'll return back a potential prompt for that. And that for that it's I also have an Olama instance running on my home workstation. So the generate image connects to Comfy for the Flux Dev model, and the generate prompt connects to Olama. Defaults to Llama 3.2, but it's configurable. So that's the MCP server. But this is not an MCP talk. This is not an MCP user group, right? This is AI Mug. We primarily discuss LangChain stuff. So I created a LangGraph workflow around that. It's a very simple, rather crude LangGraph workflow. Basically, you give it a topic that you want. It'll generate a prompt, and it'll ask you, "Are you happy with this prompt?" If you're happy, then it'll generate an image with that prompt. If you're not happy, then it'll give you a new version of the prompt, and you can just keep going, and that's until you get that. And that's where the human in the loop aspect comes in. And then at the last step, it generates the image. That workflow. Then I have a pipelines wrapper around that so that I can test it. I can use it in web UI. Why? Because. So I talked a little bit about this. The image generation workflow has ComfyUI API mode. It's got a predefined workflow. That's how ComfyUI API works, is you have to give it a workflow in the API, and you have to prefill those values so it can generate the image. And you can have multiple workflows, by the way. You just specify the workflow. If you're using it as an API, then you can specify those. You can provide the workflows, fill in those values, and it'll invoke that specific workflow to generate the images for you. The MCP server in question is hosted on GitHub. Time permitting, I will go over that as well. But that's what I discussed. This is the spec for that if you want to install it in Claude Dev. Path to UVX, Comfy MCP server, that's the name. So it's also hosted on PyPy. So you can just do UVX Comfy MCP server. You don't have to do a Git clone or anything for that. It'll just download it. It needs a few parameters to Comfy URL, basically the URL of your Comfy instance that is listening for APIs as well. Comfy workflow at JSON file, that's the workflow file that I mentioned, path to that. Prompt node ID and output node IDs are, so which inside that workflow are responsible for the prompts and the outputs. Prompt is basically a text prompt, output is going to be the picture output. The output mode is file, but this works inside if you're using this for Claude Dev, for instance, and you want to display the file. But if you're doing, if you just want to show the URL, you can just change the output mode to URL, and instead of displaying the file, it'll return the URL of URL from Comfy itself of the generated image. There's a few optional environment variables here that you don't see here. One of them is Comfy URL external. This is useful because my MCP server runs in my home network. It has access to my Comfy locally. Externally, I have access to Comfy, but it's behind Cloudflare tunnels. And like I said, desktop or doesn't know how to authenticate against that. So I do have a subdirectory subfolder inside my path that is available, accessible externally. That doesn't require authentication. So basically, what it will generate the image, but then it'll use the external image as the prefix for the generated image. That way, I can use it outside of my home network and still get access to that image. Then there's prompt. There's the Olama API base. So right now, if you only specify this, you only have access to one tool, which is image generation. But if you specify two additional environment variables, the Olama, path to the URL to Olama instance, and the model that you want to use, then it will expose a second tool, which is the generate prompt. So the nice thing about the MCP ecosystem, the SDK ecosystem, is they do ship with what's called an MCP Inspector. So when you're developing MCPs, you don't always want to have, you might not just have Claude Desktop. You don't want to be burning through your tokens just to test your stuff. So MCP Inspector is basically, think of that as a test harness for your MCPs. When you launch it, it'll, on the left-hand side, you see the parameters. Is it stdio server, or is it an SSE server? What command it needs to run with, and then if you need some additional environment variables. Once you connect to it, you have access to all the all the features that the MCP server is exposing. Because mine exposes just two tools, you'll see generate prompt and generate image. You can select one of those, you can provide the input, and then you can see the output. In this case, I was testing the generate prompt. I said, like I said, I am not very creative when it comes to articulating prompts for image generation. I can come up with an idea. So I said, okay, well, a cat holding an AI mug sign. Llama 3.2 help me out with it. And it came with a sleek black cat is sitting on a velvet couch, holding a small AI mug. Don't worry about what's in the parentheses. Sign in its mouth, and with a mischievous grin on its face and blurred cityscape background. I mean, it is AI mug. And what you see is in the response, it actually came up, it gave me URL. And again, this is internal URL. So if you try to run this on your machine, it's not going to work. But yeah. Okay, so let's talk about LangGraph. I mentioned about the Graph API. So LangGraph did release an MCP adapter recently. What that does is you might have your MCP servers. MCPs primarily give you access to tools. LangChain already has primitives for handling tools. So what that MCP adapter does is you provide it with the configuration for your MCPs, and it'll create a LangChain tool wrapper for MCPs. This demo doesn't do that because that would be too easy. But yeah, here's the tool that I mentioned earlier, right? So you start, I give it a topic, I say, and what I'll do first is we'll generate prompt. Generate prompt goes to Llama, Olama brings back a prompt, asks me in feedback. I say, no, I don't like it. Give me another one. It keeps doing that until I like the prompt. And once I like the prompt, it then sends it to generate image, and then it ends. intentionally kept it simple. You could see potentially a second human in the loop here, where it says, no, I don't like this, try one more time. But I mean, we can do that. You just do a second run and it does that anyways. So if it runs, I do that, it'll do that anyways. But yeah, now this one I specifically stuck with. Oh, here's familiar with UV. Love UV. Cam, we were running into those issues with NPX. I am waiting for an NPM equivalent of UV to be launched, because then we won't have to worry about it. Actually, NVM plus NPX is something what UV does. But it just, I mean, life was so much complicated before UV. I don't need to anymore. UV? Well, so I just want to run basic scripts, right? So for example, this server was created as a standalone script. I could hand it over to you and not give you any information. Okay, what Python version do you need? What versions of the dependencies do you need? None of that. Now, poetry, yeah, if it's a project, then yes, I can hand it over to you. It manages all that. UV also has that sort of inspirations in it. So when you're doing a UV-based project, then it basically becomes an alternative to poetry. But in this case, I just wanted a single script. And you notice that I didn't specify what version of Python I need or what dependencies I need, but I'm just giving you a script. And so I went on a tangent there, but let's come back here. So when I do UV graph PY, thread ID is, again, because this is a disconnected run, right? So this is not you run it and then the application keeps running until you are satisfied and it exits. Because I want to use this inside a chat application. I could have multiple chats, and I don't want to hold up an application instance running, while I do other stuff. So I needed somewhat of a stateless design in this one. So that's where I think, so the checkpoint, so I sort of lean into checkpointing and short-term memory for that. So you give it a thread ID, it becomes part of the configuration. I pass the flag of topic, give it the topic, and then it gives me back the response, and it ends right there. It doesn't do anything after that. I can provide my feedback by giving it the same thread ID, but this time the feedback flag of yes or no. And then it'll continue execution from that point on. And I just keep doing that. So this was again, to parallel, because a lot of the examples that you see out there are a single Jupyter notebook, which is easy to understand, but when you try to convert it over to an application, it's difficult to sort of intuit about, unless you're familiar with how to do that, which I am not. So this was the ComfyUI, and I said, well, so initially my goal was to do this with functional API only. So this is the with functional API, I could not get it to do stateless. I was running into some issues with the checkpointing. I think I had a discussion with the LangChain devs, and they said that I should be able to do it. The functionality, at least what I was doing, both Graph API and functional API are at parity. So I need to do some more. I need to do some more discovery work so I can open up either a bug report or give them more information so they can guide me out of it. So in this case, this is a stateful app, right? Well, it's not necessarily a stateful app, but basically you give it a topic and then you're stuck in that application until you're satisfied with your prompt and you have an image, or you control C out of it. I can't use this in behind a chat interface because this application will stay running until I am done with all the steps. And if I'm doing 20 of these, that means there are 20 instances of this stuck in execution loop. But this is how the execution runs. So as a UV run app py topic, cat wearing a hat thing. it created its own thread ID because right now I don't have a disconnected run. So first thing, it went to generate prompt, interrupt. It gave me, okay, this is the prompt I came up with. Do you like this? I said, no, I don't like it. And then it went through the generate prompt again. Again, you notice it's essentially the same flow as the Graph API. But this one, this had nodes and edges and all of that, while this one is basically a regular Python code. This is the second cat that came out of the functional API. Okay. Then, of course, we have LangGraph, we have MCP. Oh, let's throw pipelines in the mix. It's just a simple integration, just again, because we have human in the loop. Well, we could put it behind a chat interface. This is not the most efficient use of this, the way I've done it. I mean, there's probably you can improve on this, but because I had been meaning to test out pipeline for the longest time since Ricky demonstrated that, I said, okay, this is my opportunity. I'm going to have to do this time so I can check it off my list. So this is an example of that Graph API running, as a with pipelines wrapper. I give it a prompt. It generates the example. I give it a topic. It generates the example prompt. It says, "Do you like it or not?" Just in the chat interface, I say yes or no. It gives me another one. I say yes, I like it. It gives me the image. So, how are we doing on time? Okay. Could we walk through? Okay. LangGraph MCP pipelines. So, three scripts here. The graph was the LangGraph code that I mentioned. App py is basically the functional API app. And AI Imagen pipeline is the pipeline wrapper around graph. But it's a single file. It's not basic. It's not calling this module or anything. It has all that code inside it. So okay, let's go to the Graph API first because that's what we saw. So this is what I was this header on top of the script tells UV all that it needs. It tells that, okay, this needs a Python version greater than 310, and here are the dependencies. If I give the script to you and you have UV installed and it's a clean install, nothing else, you've never used it before. When you do UV run graph, it'll say, okay, do I have the local version of Python running? No, let me download that. Do I have these dependencies? No, let me download that. And then it'll start running it. So there is actually, you could UV add dependency. So when you're working at a project, then you just do UV add dependency and it'll just add it to the project. But in this case, because it's a script, I have to specify UV add dependency _script name of the script, and then I'll just add it here. For the Python version, it's UV Python pin version number, and I'll just add it. Okay, so this is my config for the, this is similar to if you, let's go back. Yeah. So for those who've been using Claude Desktop for MCPs, this is what you're familiar with, right? This is just that. This is a Python object with that information. It's the stdio parameters, command, args, environment variables. Command, args, environment variables. That's all it is. For the state, again, could have done better, but I need a I'm starting out with a prompt, with a topic, and then I'm having the agent, the workflow fill the prompt. I'm providing the feedback, and it's going to give me back the URL. Now, in this case, I am specifying the output mode of, I'm hard coding the output mode of URL, because I don't want to deal with downloading the file from Comfy and then re-encoding it and then sending it back to the client and then having to re-decode it. It's, I can just pass the URL over and it can just display that however it needs. Here's just an abstraction of the run tool, which is basically if you want to run your MCP tool inside Python, this is basically how you would initialize it. And once you have the session initialized, you would say session call tool, name of the tool, and arguments. And that's how it'll just, you're just calling the tool that way. Yes, go. Yeah. Yep. You could, but Comfy offers an easier way. You can download a workflow JSON file. So when you have that workflow that you're testing out inside Comfy, when you're happy with the workflow, you can export it out in external API mode, and it'll give you a JSON file. And that's the JSON file. That's what I'm giving here as the workflow JSON file parameter. Mm-hmm. You start the JSON, yeah. 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 But yes, you could handcraft, if you're familiar with their schema, you could craft that JSON file yourself. Comfy will, because basically all that is it's the representation of that workflow in JSON format. As long as those nodes are available and you've made the right connections, it'll work. So this is the tool call. This is again, when I'm explicitly calling a tool, I'm just saying, yes. Yeah. Yeah. Sorry. The question from Cam was, can you programmatically create the JSON for Comfy, to represent the workflow? Yeah, and the answer was, while you can, it's a complex, as long as it's a complex schema. If you have an existing workflow, you could just download the schema from Comfy itself. But you could, as long as you have represented the right nodes and stuff. And you could handcraft, you could craft the JSON programmatically. Yeah. So run tool. So then I have wrappers around my tools that I have. Generate image, which takes a state. These are the nodes, by the way, for those who are familiar with LangGraph. It takes state and it returns a state. If for generate image node, I'm looking at the prompt. I'm calling the tool explicitly, and I'm doing, giving that, returning the URL. For prompt feedback, it's exact same thing. But no, for prompt feedback, I'm making an interrupt. It's not calling a tool here. It's the human in the loop interrupt. Basically, what it's doing is it's from my state, it's saying, well, this is the topic, this is the generated prompt, and the action. Again, this is just if you're creating a UI, you want to display that. This is just hard-coded stuff. You don't need this if your application is handling that. But in this case, I just wanted to have it here. And then process feedback is once we get the input from the user. This is a conditional edge, by the way, where it says based on the feedback. If I don't give any feedback, which means that I accept it, or if I explicitly say yes, then go to the generate image node, follow the generate image edge rather, or follow the generate prompt edge. I build my graph workflow, add the nodes, specify the starting node, add the edges, add the conditional edge, and then this is basically the representation of the flow that you saw here. Then in the code, I have some code here to handle the argument processing, some setup work, and then I'm initializing a SQLite saver for checkpoint, so that again, because if I don't use that, it'll use memory. After every execution, that memory is gone. So because because I want human in the loop to work properly, I need it to manage state externally, and that's where this we're initializing this saver. The file name is hard coded, but we could make it configurable. There is also, by the way, out of the box, LangChain provides a Postgres saver. So if you're using something like Superbase, for example, or I think LangGraph platform also provides you Postgres, I believe. So it kind of makes sense that they're providing you with the check pointer for that, so you don't have to worry about it. Inside there, I compile with that check pointer. First thing I do is I check the state of the graph. Well, I don't know whether this is my first run or I'm coming back. If this is a first run, then my prompt is going to be just this, topic, and whatever I give it in the topic, I give that. But if it is a feedback run, then I say, okay, don't use that prompt, use this one. Just whatever feedback I give, resume with that feedback, and then I just stream from there. Then there's a conditional here. If you do encounter an interrupt after running this, then go ahead and print what you receive in that interrupt. If it is a generated image, then go ahead and provide give the output for that and execute and end after that. So this was the Graph API run. Functional API is not that different, except so this part is the same. This is the same. Tools, the nodes, instead of nodes, I now have tasks. And they are doing the same thing. They're taking the topic. This is a bit more ergonomic. Taking the topic, returning the response. All it's doing is it's calling the tool, the MCP tool, the tool that the MCP is exposed, right? So, but I'm explicitly calling those. You could just make this a React agent and say, these are the tools I have, work with it. And it would be a very simple workflow. But then, because I needed a specific, I had a specific workflow in mind with human in the loop, I went with explicit. Okay, at this step I wanted to call this tool. At this step I want to call this tool. But so, if you're thinking in terms of what Claude Desktop does, it says, okay, I have all these tools, and that's more like a React agent at that point, right? So you have access to these tools, look at the query that I have, and choose the correct tool, and display the output. Is basically the primitive that functional API brings, and that's your entry point into your functional API workflow. This is where the checkpointing happens. This is your, so workflow topic is the same as graph, invoke, parentheses, topic. It's the first step into the flow. But inside here, this is all the code there is. So it's going in, it's checking to see first. If it's I'm creating an endless loop here. Again, that's that's this loop, but programmatically. Do this until the user says they're happy with it. When they're happy with it, go ahead and generate the image, exit. So this code represents this graph. But instead of doing nodes, states, edges, you have this in like 20 lines of code. Yeah.
Keeping them aware, interaction with the agentic graph, refining a prompt in a loop until it gets a successful return. Then it passes off to an MCP app for the image.
The prompt generation and image generation are both MCP. Yeah. Well, it's encapsulated in 20 lines of code. Of course, there's a there's a little bit of this there. You have 4 lines or 3 lines for each tool wrapper, and maybe another 5 lines for setup and stuff. Yeah, not a lot of code.
The front ends to Flux, maybe. Like, how many lines of code would that be?
It was more than this. It was more than this. Yeah. Functional API. I mean, because if you think about it, could you do this workflow without any of the functional API stuff? Yes, you do it in Python. You're managing. You're responsible for managing the flow and the state, managing the state. And so nowhere here am I making calls to say, hey, by the way, this information, put it in a database somewhere. So when I come back, I check the database and I make those calls. None of that. When I'm doing this, or especially in the graph one, it's not that evident here, but when I enter this flow, it's already checking to see, because when you initialize it, you specify the thread ID. It's checking to the checkpoint to say, hey, do I have any existing state for this thread? Okay, let me bring that over. Let me have it available here so that the developer can use that to make informed decisions in the code. This one is a little bit more simplistic version of that, but yeah, the main function actually is quite similar to the graph one, but this piece of code might be a little bit easier to reason about for those who are coming from strictly a programming background and than say, oh no, this was a statement. Student. This. Yeah. If I would say that if functional API would have been introduced first, then a lot of the sort of grievances that people had, developers mostly had about LangGraph being too convoluted to understand, would not have existed, because it's easier to reason because this is how you code anyways. And now by introducing some of these decorators and LangGraph primitives, it's actually you're getting you're offloading all of the state management to LangGraph. It's doing it behind the scenes, similar to how with Langsmith, all you do is specify a API key, or an environment variable. You don't have to specify anything else, and it just does it for you. Could you do that by hand? Of course you can. That's bringing in a whole different library, sprinkling a whole lot of sort of log statements across your code. But when you're doing it with the primitives that LangChain provides, all of that just becomes transparent, just blends away into your code. You don't have to work, you don't think about that anymore, because so this was the functional API. The only thing that remains now, we're good on time, right? 8. Okay. 8 lines. So pipeline has a very simple structure. Pipeline is, again, to recap, to extend, to add more models or workflows, make them available within OpenWeb UI. Again, these are the environment variables that I need, and configurable values that you. So this for one reason went in heavy with the plumbing jargon. So valves are configurable values for your pipelines, because you're turning valves to change the pressure and stuff like that, right? So anything that is configurable is a valve. So when you install a pipeline, those become values that you can then configure. on the pipeline. So in this case, because I want the user to bring in their own Comfy URL, their own external URL, I want it to be available to them. Stuff that I don't want them set, I'll just handle it and I'll not expose it as a valve. Initialization, this is where you take those valves and you're filling in those values. Mostly pulling it from environment variables if they're present. If they're not present, then they can fill it in. On startup, again, this will look familiar. You've seen it like 2 times now, but this is your standard IO server parameters for the MCP server. In this case, I did provide these extra ones, right? So Olama API base for the Olama instance, and prompt LLM to use that's already present on your Olama for topic to prompt generation. I like to bring in the extra environment variable of path that helps sometimes I found with the command resolution. So when you're using something like UVX or NPX, you don't know how the MCP, whatever host that is starting the MCP client, what environment variables it might be passing in, or it might be altering it. This sort of makes sure that your path, at least your path, stays preserved. And I don't have to worry about providing a fully qualified path anymore, because I know that it's already present in my path. It just works. This code is the same from Graph API, except that it's now attached to the member variable. Startup shutdown, we're not doing anything there. There is a concept of inlet and outlet, again, plumbing terminology, but think of it this way. When you might want some control over what input users are providing to your model, to the workflow, and what output you want to you're presenting to the user. So say, you don't want people to just abuse, your pipeline that you're creating for, because they might use it for all sorts of nefarious stuff. And so you could put in inlets where basically say, okay, before I pass my input to the workflow, I'm going to do some, I'm going to make sure that it's good. It's sort of like guardrails. Outlet is, well, you sometimes want to also watch what response is being sent back. So an example would be, say if it's something to do with medical records, and you're using an LLM tied to your patient record system, and you want to make sure that accidentally PII is not leaked. So you could have a process that monitors whatever is coming back from your workflow and says, hey, just scrape this for any kind of PII, and before you return it to the user. So that's where it is. The way I'm using this, so I'll come over to that later, but pipe is basically your construct. This is your main function. Anytime you send a chat message, it goes through the pipe. It has a list of all the historical messages. Some additional messages, some additional information is stored inside body. For example, the chat ID itself is inside the body dictionary, which is what you'll notice that I'm using as a thread ID, because it's going to be unique to that chat. Inside here, this is basically the same code as the Graph API, the main function. Because pipe doesn't offer an asynchronous flavor, I'm just wrapping it inside of coroutine here. So that's the extra bit of thing. Two is again the same thing, generate prompt. This is all the same code from there, prompt feedback, process feedback. What's different is the Graph API returns not the image itself, but the URL of the image on Comfy. If I just return that, that's fine. It will send that image and that link will show up, but then you'll have to click that link for it to open. So what I'm doing in Outlet is I'm inspecting that. I'm saying, okay, hey, do I have a URL in there? I do. Okay, let's go and remove that message, transform that message object, remove it from the content body, and actually add it to the file itself. So there is a files property, and you can provide an image URL to there. And what that means is that the OpenWeb UI interface now knows, okay, I have a file that was returned to me, so I should display it differently. So if it was for example, if it was a RAG and setup, you don't want to, and you don't want to just show, oh, here's the response from the RAG, but you also want to include sources. So that would be somehow you could do it. So if your RAG system gives you links to your sources, you could say, okay, I have these sources. I'm going to package it up into the files object, so that they can click and they can just open up those in their interface. So that's, yeah, a whole lot of mumbling here, but yeah, that's the, let me see if I can, okay. So this is the MCP. In fact, before I go there, because I know this, I don't know if this will work or won't work, but yeah, that's why I have screenshots. But yeah, so this is how you would install MCP, and this is how you would configure it. So this is the AI Imagen pipeline, and I have the URL for my internal service. So I don't have to go through Comfy to just post a request, but when I'm sending the URL out, I want the externally accessible URL. So I'm giving it that. This is the path. I had to upload the JSON file, so then I'm giving it the path to that JSON file for the config workflow. Prompt node ID, output node ID, Olama instance, and the model to use. Let's go here. Say, from that's how creative I am with prompting. Okay. So it came back, generated an image of a colorful parrot perched on the fence post, wearing a wide-brimmed cowboy hat and holding a miniature guitar, because I said, from Austin, Texas, set against a vibrant backdrop of a Texas sunset over the rolling hills of Austin. Do you have rolling hills in Austin? Okay. I do like this. Yes, Cam. Okay. That prompt generation works. I'm just going to try and see if image generation works or not. It might still bomb, which is fine. Because it has, so Comfy is running, but the image may not be loaded. Okay, there it is.
That's.
Yep.
When you talk about.
Yes. Mm-hmm. Yep. Yep. No, so you see the pipelines there. So pipelines are here, but if you want to configure them, you have to go to the admin console. To click the drop down, find the specific pipeline, and then you give you all the valves associated with it. By default, it'll have let me see. Let me show you the code for this one. So if you notice up top here, no, not here, here. So we're getting them from the environment, but if it's not there, we're just putting gibberish inside there. So that's just a hack to provide placeholder text, right? So, okay, what do I put in this valve? Well, you need to put your Comfy. So I could put in like a full explanation here for that. So it might look like it already has the value, but you need to go in and just provide the correct values within the in the admin console. So yeah, I'm already here. Okay. So pipeline image gen. Okay, when I do this, so I click the pipeline valves. I select the pipe that I need to adjust, and then it'll show me the value. So if I go and if I do Comfy MCP pipeline, which is a precursor to this pipeline that I showed, this one just takes in the topic and generates the image. It has all it has is a connection to the MCP. It doesn't have any LangGraph. It doesn't have human in the loop. Nothing. It'll not create a prompt for you. So if you already have a prompt, then you would go and do that. So in this case, I have less valves here because I don't need the Olama component here. But for AI image and pipeline, I have a couple more, and these are the values. Yep.
That's all the same pipeline server.
It's on the same pipeline server, yes. I only have one pipeline server set up at the moment. But I sort of rigged up the requirements text file for additional dependencies that I needed.
So once you like say you're starting, like you already know the pipelines apply.
Yep. So I don't think that you can download from here. Well, you can use, yeah, you can download from here. This is what you're talking about? Yeah, you can just upload. You can upload, either you can put your, like, for example, since this is available on GitHub, you could just do this and paste it here. When you click here, it'll install it. And when I say install it, it's just copying that file from GitHub and placing it in a folder. So if there's any additional setup work, besides filling in the pipeline valves, for example, this one does require you to additionally upload the JSON file because it expects the JSON file to be on the server. So you would need to make sure that it's present there. But yeah.
Are you API?
Yes. Yes, I need to, so I can already use it for a lot of the use cases, like, when I don't need the application to be stateless, but I do need to figure out what's broken in my implementation that's preventing me from having a similar flow as I had for Graph API, where I could just, launch it, give it a thread ID, and have it work on just that thread ID. So that's the piece that I need to figure out why it's not working in my instance. But otherwise, it's a lot easier to sort of, I think with the Graph API, it sort of removes you from your programmer hat into a, sort of like a workflow designer, and that context switching sometimes can get in the way. But when you're just coding stuff, okay, yeah, this is how I want to do. I want it to ask for an interrupt here. I want it to do, loop through here. It took a lot less time to code the functional API. I started with the functional API first. I was done, in a matter of minutes, and I had to go back and look through. Okay, how do I create? Even though I thought I was more familiar with the Graph API, but I had to go take a step back and say, okay, how do I create this in a graph? How do I break this apart into different nodes and put it together? I don't care about the visualization aspect as much. I think what I do miss from the function from the Graph API is the whole the state management side of things, the state machine side of things, right? So where that was the nice thing that I really liked about the Graph API is yes, it takes a little bit more planning, but you could really modularize your application, and you could sort of have these. You could build in, these in a more modular way, if I can call it that, work on individual nodes in isolation, because that's what it's supposed to do. It's, a node is supposed to takes an input, works on it, sends the output. That's it. And then you're connecting different nodes together to get it to work. Whereas I think going forward, even if I now need to work on a graph API, I might still start with functional, because I think functional is a lot easier to prototype it.